Hello everyone. In this particular problem, we are going to solve the ICR for this particular problem. The problem is from page number 232, first problem. In this, the data is given as, let me just read the question. As the figure shown, the disk rolls without slipping on the horizontal plane. You need to note one thing down, which is that the disk is rolling without slipping. So it means that wherever the disk is having contact with the horizontal surface, there is no slipping happening, which will indicate one point we will discuss later. It is saying that it is rolling without slipping on the horizontal plane with an angular velocity of 10 revolutions per minute. So here the data is given in somewhat a different manner, which is saying that n is equal to 10 revolutions per minute. Now always we had it in terms of radians per second. Here we are having it in terms of revolutions per minute. So we need to convert that. Let us go through the question again. It is having an angular velocity of 10 revolutions per minute in clockwise direction. So I'll just notify it over here, which is in clockwise direction, omega. Let me just name it as omega. And the bar AB is attached as shown. So a bar AB is attached as shown, where A is, let us say, pin joint with the roller, and B is simply a free end where it can slide on the horizontal surface. They are saying that the point B moves along the horizontal plane, and they are asking us to determine the velocity of the point B for this given instant. So by this given instant, they mean that for these given dimensions and all, we are just asked to find out what will be the velocity of the point B. So first of all, as I told you, we need to know one thing, that if my roller is rolling without slipping, definitely the ICR will be exactly at the point which is in contact with the horizontal surface. So by default, without even thinking much, we just have to note this I over here as the point where my ICR for the roller is located. Now the next step is to get the omega in radians per second. So how to convert this n into radians per second? Yes, it's very easy. Omega will be nothing but 2 pi n by 60. So when you substitute the values, you should be getting omega as 1.047 radians per second. Now, as soon as we get the location of the ICR I for any given object, we can immediately find out the velocities of any point on that given object using the same ICR I. All we need to know is the distance from that particular point to the ICR, and by just drawing the velocity perpendicular by joining that line, we will be able to find out the velocity. So let us just do that. I will just first of all join A to I because I want to know the direction of the velocity of A. Why A is required? Because A and B are on the same link and they have asked us to find out the velocity of B. So if I get the angular velocity of AB, I will be able to get the velocity of B. So velocity A will help me in doing that. So I'll just join A to I first of all. Let me do that. Here I would like you people to also, just pause the video and get all the directions of the velocities, so that when you are solving the problem, you are also learning it. So as soon as I do that, I will now just join a perpendicular. So you can see the perpendicular is just near about along to the same line. It's a little less than that. So just make sure that when you are calculating angles, it doesn't make any kind of a mistake. So this is my VA. Now from this given link, A is, since it is on the circle also, I can locate VA with the ICR of the circle. Now A is also a point which is on the link AB. So A shall be having its center of rotation as the center of rotation for AB along as it is. So how do we go for that now? I need to locate the ICR of this link AB. For that I need how many directions of velocities? Yes, I need two directions of velocities, of which VA is known and there is no brainer because B will also be moving in just the horizontal direction. So if I'll just draw a horizontal line or a horizontal velocity for B, let me draw it in this direction. This is VB for me. I can simply say that now I know the two directions of the velocities. So what I'll do is I'll just join it by drawing perpendiculars. So draw perpendiculars from both the lines or both the velocities. And once you do that, you will be able to locate the ICR of this given link. So somewhere over here I should be having the location of the ICR for my link AB. This is the location, yes. So this is IAB, and I can say that now AB is going to be rotating along this given line, along this given point, which we may also call it with omega AB. So my only job is to just get velocity VA, then find out omega AB, and using omega AB and IB I shall be able to find out VB. So let us just start working out on that. So we will first start with the VA. For VA I need to know the distance IA. Do I know the distance IA? Yes, it's very simple, because if I join this as a triangle with the centers, so you can see that IO and OA, they are nothing but radius. So this will be radius root 2, is it not? So radius root 2, for which the radius is given as 600 millimeters. So radius root 2 will give me the distance IA. So I can simply write down IA is equal to 600. So IA comes out to be somewhere around 848.14 millimeters. So now we have got IA. I can simply find out VA. So I'll just write down over here. VA can be written as IA into omega. So we know very well what is IA, which is 848.14 into omega, which is 1.047. So this gives us VA will be equal to 888 millimeters per second. So now VA is also known. Now my next job is just to find out IAB to A, this distance, and IAB to B, this distance. Once I get that, I will be able to find out omega AB and VB all together. So let me just consider this particular triangle AIB. So I'll name it as BAIAB. So in triangle BAIAB, in the triangle BAIAB, I can use the sine rule. Using sine rule, I can write it as AB upon sine of this angle. What is this angle over here? This angle, this is 45. So if this is 45 and this is 90, if I extend this as a triangle, then this also has to be 45, correct? So this will be 45, will be equal to AIAB upon this particular angle. So right now let me just think about how will I find that out. So I'll just leave the space for that. Shall be equal to BIAB upon sine of this angle. So first of all I need to find out the angle over here, which is this angle. Let me consider this angle as theta. So if this is theta, this has to be 90 minus theta, and if this is 90 minus theta, so this will be, we can find out later on by using 180 minus 45 minus 90 minus theta. So what is this angle? First of all, theta is equal to, this is 600, which is just the radius, so we can say this is the radius, plus 300, which is 900. So theta can be written as, I'll just work out theta over here. Theta can be written as tan inverse of 900 upon 1200, which is a common standard ratio, which is 3 by 4. So I can simply write down theta is equal to 36.87. Now if theta is 36.87, this has to be 90 minus theta, which is 53.13. So this comes out to be 53.13. And when you subtract everything out, so 45 and 53.13, 180 minus the entire thing, you should be getting this angle, which is 98.13, sorry. So this is coming out to be 98.13. Now AB can also be found out using the same way. I know theta, or in fact simply I can say that AB is also equal to, I'll work out AB also over here, under root of AB is under root of 900 square plus 1200 square. So this will be equal to 1500. So I can write down AB is equal to 1500. And using these two, I can find out AIAB, which is equal to, coming out to be somewhere around 1697, and BIAB, which is coming somewhere around 2100. Now using this particular ICR, I will be finding out my omega AB, because VA can be written as AIAB into omega AB, where VA is known to me, VA is given as 888, AIAB I just found out, which was 1697, into omega AB. So from here I can say omega AB is equal to 0.5232 radians per second. In such kind of cases, you can actually write omega AB to be somewhere around 3 to 4 digits when it is in decimals beyond 0, near to 0. Now if I know omega AB, VB can be written as BIAB into omega AB. So VB can simply be found out over here with the help of that angle, with the help of this length, which I have already found out over here as 2100. So this will give me the final answer of VB. So VB comes out to be somewhere around 1.099 meters per second. Okay, we can actually write it as 1099 millimeters per second as it was going through it, or we can simply write it as 1.099 meters per second. So I hope you have understood this problem. Thank you.